Welcome to Turn Right Machine Works. My name is Keith. Okay, we've got Legacy 32 rudder up here, and that's just the name of the boat and basically the hull size. This is a setup where I'm going to be boring both ends, the pintle and the main stem. I went ahead and I sharpied this area up here, and I took my calipers and I created an arch for the center line. From that center line, I want it from the very bottom of the valley here equal on both sides, so that I know that I'm straight in line. So that's what I've done. I went ahead and I take one 800 or just slightly below that, and then I came over here and I measured the same thing. Now I'm going to bring you around to this side to show you how I wrote this. Diameter of the pintle hub is smaller than the main stem hub, so I had to compensate so that I can clamp it down, support it, and hold it. So I'm going to bring you around so you see this. I have a round stock down in here so that I can lay flat bar on each side, and I keep a box. I keep a box with goodies in there, and I just call them, because there's all kinds of good stuff in there. So I have a 1/4 inch in here, and then I needed to have an extra 16 because I measured down from the bottom and I measured there, and I keep spacing it until I get it up. Of course, you need this side to be exactly equal to this side because we're working that V to hold it center line. So anyway, I got it set up, and that will be the stack pack basically, so that when I turn this rudder 180 degrees and I go to machine this in, that same pack is going to want to be at the forward end when I rotate this thing around. Alright, this rudder happens to come back here close to the groove that I have for the true north, and I find that just putting a piece in here and I slide a little slug in there, and then I don't have to clamp anything in here to help the pressure from drilling the rudder out with the round stock. So I can just drop this in here, and that slot actually is a good brake or support so the rudder doesn't travel from any pressure on the tool bits. Now I'm just going to pull this clamp off of here so you can see this a little easier. This is already tightened down, so these are nice and tight in here. But I level this out until I have a spacer that goes in here, and I almost use them like feeler gauges, to where I get it to, I put the stack up, there's a 1/4 inch, there's an 1/8, and then here's a piece of banding material, which I use a lot for shims. And I get it to just be barely slipping in and out without any rocking. And then when I clamp this down, sometimes these hubs aren't quite square, so they want to take, and I want to try to keep the blade from bending down or bending up like that. So I go ahead and I create this before I tension everything down this height. And then after that, just to ensure that I am holding the blade from flexing up or down so that this line stays straight. It's very important that the alignment from the main stem to the pintle remain in line so that you have ease of spinning or operating of the rudder. Alright, we've drilled and reamed out this side here, and I just wanted to kind of set this up and show you how I go ahead and 180 this piece. Also, before I undo these clamps, this little stopper that I put back here never got any pressure against it, so the clamps and everything else was actually holding this blade strong enough to take the drill pressure and the ream pressure. Alright, so basically all we do is we undo our clamps. See, this is the shim pack I put underneath there. Most of the time that shim pack just comes right back into the same play because all we're doing is spinning at 180. So we lift it up, we jump out our chips if we got any. We go ahead and we put our pack down at this end here. Move that over there. We set it right on there. We go ahead and put our piece back in here. Pull that against there. We lift this up and we make sure that this is right at the edge, so that we're resting in the same spot, so that anywhere the curve is, we're kind of like right in that same spot. All right, now we take our shim pack, we slide it in here till we just have a little bit of play on it, like that. That's all we need. Okay, we're ready to go. So a drill point in here. Actually, we gotta clean out these chips here, but let's go ahead and fire it up. And there we are. All right, we've kind of moved everything to the side. We did a preliminary vacuuming. We do have a couple other chips up here. All right, now I'm going to go ahead and break loose my jig because I want to put the vise up here. We have one last bronze piece that I'll be using the head and 90 degree from the table here. We have a place over by the Bridgeport there, and that's where we store that. We just take our 2 T-nuts from there and there, the other 2, put the bolts and the T-nuts up in that little box, and that jig is ready to put on anytime we want, and it's that simple. And that jig lets us do all the holding for those horizontal rudder jobs, stern tubes, through hauls, skegs, any of the cylindrical items where we need to get in, we need to do a bore. Some of them just a rough location, but holding it true in line with where it needs. And also holding those items that you can't spin in the lathe. All right, I gotta vacuum this up and we'll get the vise up here. We'll get the next project. I just want to hit one item on this next project, how I do it in the K&T, and that'll be wrapping it up here shortly. Okay, we got the L32 Skeg in here, and there's one flathead bolt that's got to go in this way into this little ear. The rest of them come underneath and hold the Skeg to the keel. And so this setup is, I've done this numerous times because we get these over the years. We get several of them a year to make, and this is my setup that I use all the time. So once I've got done and I got my head in the horizontal position, I go ahead and I put my pointer in here, and basically it's 1 inch up off of here, and then targeted center line with the point here. And we're going to go ahead and we're going to drill through with a drill. And then we got this tool that we made up, and this is just a brazed high-speed bit, and I've taken and milled this angle right into this piece, and I silver soldered a 1/4 inch tool bit right in there, and then I just go ahead and I give it the relief here and some rake here. Every once in a while I have to touch it up, but I draw that backwards, and that is the angle for countersink. kind of simple. So this is, I've already taken and I set this up. You see my head and you see how close this is. These come and almost touch right in here. In fact, actually, I got to cheat this. Bringing it down so that this is a little bit lower. I got to cheat this angle slightly. But the angle I'm cheating it is very, very slight. And the flathead is still going to mount in there. They're going to be pistol drilling the keel, and I'm going to be coming in just as close as they would be able to do that. All right, I'm going to bring you in close and add a couple different angles so that you get to see this operation. Okay, this is a 17/32 drill bit. I mean, not a 17/32, a 35/64. Just a 64 with over a half, so that we give a little bit of clearance. Okay, now we go ahead and we pull this bit out and we slip this backwards through our hole here. As I've had a problem where sometimes you try to make this hole a ½ inch and it's too tight to actually force this through and get the feel of it. All right, we advance our tool so that we can grab a hold of it here. And all we're doing is just trying to get in there and barely grab it, just making sure that we're not hitting back here. All right, I like that. All right, we're gonna slow down the speed now. And we stay in the same direction. I made the cutter the same direction. And I've already had it figured out so that I can get the width that I need on various holes. This happens to be 1 inch on the width of the countersink at the top. So that's kind of what we're gonna be making it to. All right, zoom you back in here. Okay, and I'll find my mirror. Okay, I found my mirror so that I can watch, because I'm cranking from the table back here. Now I'm just feeding this by hand. Okay, now I just stopped. I don't have to, I just backed off the pressure so it didn't have any tool pressure. And all I'm looking for is 1 inch across here, and I'm about 30-40 thousandths more to go. This is like plus or minus 64th or so. Nothing's gonna rub across the outside. Okay, I've got 1 inch, just slightly a little bit above 1 inch, that's fine. All right, what I do now is I go ahead and I break the drill, the tool loose, and take it out of here. Then I can move my equipment away. And that's how I put that flathead hole in the vertical space where you couldn't get a drill back in here, you know, in this position to get in here and properly do that. And you know, I get a nice machine finish in on here. And this tool is probably back countersunk, oh, I don't know, maybe 100 plus holes. Well, there's covering a little bit of, you know, I love playing with my K&T, but it's not so necessarily the K&T. It could be the Bridgeport. It could be anywhere where you can get your head to turn horizontal and you'll be able to get in line with your table, and you can make you can make jigs and you can do work in the horizontal plane. Taking and lining up your work and then following up so that your setup doesn't change 100%, meaning the head was in a 90 here, so I took advantage of doing everything that I need to do in a 90 degree, and then when I'm ready to do something else or another position of cut or a different type of machining, I can change the head and do that, so you're not going back and forth on your setups. Keep them all in line. So you might have to shift your parts around a little bit, but the same token, you get to eliminate some of your time in your setups. And this was just, I saw this coming in. I just wanted to, I've done this before with the other setups, but I just want to show you another way that I'm actually doing it right here while we're playing with the horizontal machining, even though it's not a horizontal boring machine. That happens to be my most favorite machine to run, and that's why you see me run my K&T a lot like a horizontal boring machine, except for I don't have the in and out spindle, but I compensate with the table and the jigs off of the table. All right, so until next time, get her done.
get her done.